Alright, 4.2, we're going to be working with quadratics that are in vertex form and how to graph from that form. Here is vertex form. Okay. That's vertex form. Now that's different from standard form. So there's a difference here. You got a set of parentheses being squared. It's very important. Here you don't have a set of parentheses. You just have x squared. Alright, so for example, we're going to graph this one. Alright, so the first thing you do is we want to find the vertex, which is hk. So the vertex deals with this and this. So here's h, here's k. Alright, so h is 1. So you always want to think of opposites. It's -1, opposite is 1. So the vertex is at 1. And k is, in this case, is 3. And that always stays the same. So whatever that is, stays the same. It's just that the vertex, the x-coordinate, is always opposite what's inside the parentheses. So if this was a +1, it'll be a -1. But since it's a -1, now it's a +1. So here's my vertex. Let's graph it. Alright, since we have my vertex, now this right here is my axis of symmetry. Alright, so axis is at 1. Now my y-intercept, or since it's not a standard form, this is not your y-intercept, all right? Because only in standard form will that happen. So that means I got to come up with 2 more points. So I'm just going to come up with another point for x. I like to pick 0 if it hasn't been used yet. So I'll put 0 for x. So now do 2, 0 minus 1 squared plus 3. So this becomes 2 -1 squared plus 3. And square that becomes +1 times 2 is 2 plus 3 is 5. So my other point is at 5. Now, since we have the axis of symmetry, we just reflect this over. So the distance from here to here is 1. So the distance from here to here has to be 1 as well. And now here is my graph. If you notice, A still is A, so A is positive. Alright, it's positive, so we know it's opening up. So that's a good indication I did this correctly. Let's look at another example. Alright, so let's find the vertex. Vertex, remember, is hk, which is opposite of 5. Positive 5 is -5. K stays the same. So there's my vertex. So I'm going to go -5, +2. Axis of symmetry. Now let's pick a point. Let's do 0. Alright, let's pick 0. So I plug 0 on this. I got -0 plus 5 squared plus 2. So that becomes 25. See, the neg's on the outside of the parentheses, so it'll always be negative. So that's -23. So if I go 0, see, I only have my graph going down to -10. Alright, so let's pick another point. Alright, let's not pick 0, so let's pick something else. Let's pick, I don't know, let's pick -3. Alright. I keep picking points until I find one that falls within my graph. Right, so -3. So we have parenthesis -3 plus 5 squared plus 2. So that becomes +2. Remember, the negative's on the outside of the parentheses. That always stays negative. Okay. So that is -4 plus 2, so that gives me -2. Alright, so -3, -2. Now I reflect it over the axis of symmetry. That's the reason why I do this dotted line, to help me reflect it correctly. So from here to the axis is 1, 2. So from the axis, I'm going to go 1, 2 on the other side. And there we go. Make sure you draw curves. There should be no straight segments or lines in here, or straight lines in here, okay? Now, if you look at A is negative, so that tells me it opens down. And it opens down. So good indication I did it correctly. One more example. Alright, so let's find the vertex. Alright, the vertex is opposite what's inside, so it becomes -1. On the outside stays the same. So -1, -4. Axis of symmetry is at -1. That helps with reflecting the point. Let's pick 0. So that's 1. So 1 squared is 1 times 2 is 2. 2 minus 4 is -2. So 0, -2. Now from here to here is a distance of 1. So on the other side, from the axis, I'm going to go a distance of 1. Right? And then here's my curve. A is positive, so that means it opens up. And it opens up, so indication I did it correct.